The moon is bombarded with meteors regularly, but most of them are no bigger than specks of dust. Over the years, significant impacts have been observed. If a meteoroid comes close enough to the moon and enters the moon's atmosphere, it vaporizes and turns into a meteor or a streak of light in the sky. So the question is, are meteors stars or do they just look like them? Well, because of their appearance, these streaks of light are sometimes called shooting stars. Despite the name, meteors are not actually stars. What we see is the passage of a glowing comet, meteoroid, micrometeoroid, or asteroid through the moon's atmosphere. After being superheated, it glows incandescent because of collisions with air molecules in the upper atmosphere. It produces a streak of light with its rapid motion and by scattering glowing material in its wake. The word meteor comes from the Greek word Meteōros, meaning high in the air. Welcome to Brainbender's Solarium. Join us as we travel through space and explore more about giant meteors and what happens when they hit the moon. Spanish astronomers in February 2014 recorded the impact of a meteor weighing about 400 kilograms. It traveled at about 64,374 kilometers per hour, or about 40,000 miles per hour, and resulted in a 40-meter wide crater. Just 6 months ago, a NASA telescope observed the effect of a 40-kilogram rock-like object. The actual yearly rate of these impacts is unclear because astronomers have not observed enough of them. So, are there different sizes of meteors? Most meteoroids that become meteors are about the size of a grain of sand, usually millimeter-sized or smaller. We can calculate meteor size from their mass and density, which we can estimate from the upper atmosphere's observed meteor trajectory. Meteors may be giant or occur in showers that emerge as the Earth moves through a stream of debris left by a comet, or as random or sporadic meteors not associated with a particular stream of space debris. Meteors become visible at a distance of 75 to 120 kilometers, 250,000 to 390,000 feet, above Earth and disintegrate at altitudes of 50 to 95 kilometers. Meteors have a roughly 50% chance of a daylight or near-daylight collision with the moon. Most meteors, though, are observed at night when darkness allows fainter objects to be recognized. For bodies with a scale greater than 10 centimeters and up to several meters, the meteor's visibility is due to the atmospheric ram pressure, not friction, that heats the meteoroid so that it glows and produces a shining trail of gases and molten meteoroid particles. The gases include vaporized meteoroid material and atmospheric gases that heat up when the meteoroid passes through the atmosphere. Most meteors glow for only about a second. So what happens when a meteor hits the moon? According to a new study completed in January, the meteor struck the moon's surface at 61,000 kilometers per hour, when our lunar neighbor was in total eclipse. Researchers saw a flash of light during the eclipse on January the 20th to the 21st. The flash occurred when the foreign object collided with the moon and shaped a crater about 10 to 15 meters in diameter. It was traveling fast enough to have been able to cross the United States in just a few minutes. But luckily for Earth, it slammed into the moon instead. So, what exactly was observed from this impact? Astronomers measured a flash of 0.28 seconds, the first to be captured during the lunar eclipse. Lunar eclipses happen as the moon moves through Earth's shadow in its regular orbit around our planet. The moon turns a reddish or orange color because only sunlight around the edges of Earth's shadow can reach the moon's surface. MIDAS, or the Moon Impacts Detection and Analysis System, is a network of 8 telescopes in southern Spain that monitors the moon's surface. MIDAS scanned the flash in different wavelengths, revealing more information about the space rock that hit the moon. Scientists estimate that the rock was approximately 45 kilograms in mass and about 30 to 60 centimeters across. After the impactor crashed into the surface, the debris generated had an estimated peak temperature that was about as hot as the sun's surface, about 9,750 degrees Fahrenheit, 5,400 degrees Celsius. Is it common for the moon to be hit by different-sized meteors? Researchers have said that the moon is struck by tiny rocks more frequently than Earth because it has such a tenuous atmosphere. In contrast, Earth's atmosphere is dense enough to burn up many space rocks before they can reach the surface. Scientists have added that watching the flash is extremely important because it cannot be duplicated on Earth. It would be impossible to reproduce these high-speed collisions in a lab. Observing flashes is a great way to test our ideas on precisely what happens when a meteor collides with the moon. Scientists say that knowing the lunar collision rate is especially important for astronauts' safety, who may be venturing back to the moon's surface relatively soon. NASA astronomers have been monitoring the moon for signs of meteors hitting the lunar surface for the past 8 years. Lunar meteor showers have become more common than anyone expected, with hundreds of visible impacts occurring each year. They have recently seen the most significant explosion in the history of the program. According to Bill Cook from NASA's Meteoroid Environment Office, an object about the size of a small boulder hit Murray's lunar surface in Brigham on March 17, 2013. It exploded in light about 10 times brighter than anything we've ever seen before. Anyone looking at the moon at the time of impact could have seen the blast. There was no need for a telescope. The impact site glowed dramatically. Ron Suggs, an analyst at the Marshall Space Flight Center, was the first to notice the impact in a digital video recorded by one of the monitoring programs using 14-inch telescopes. It was so bright, he recalls. The 40-kilogram meteoroid measured 0.3 to 0.4 meters wide, hit the moon, traveling at 56,000 miles per hour. The resulting explosion packed as much punch as 5 tons of TNT. Cook reports that the lunar impact may have been part of a much broader occurrence on the night of March 17th. All sky cameras picked up an unusual number of deep penetration meteors right here on Earth. He says these fireballs were traveling along nearly identical orbits between Earth and the asteroid belt. This theory implies that meteoroids pelted the Earth and the Moon at about the same time. My working hypothesis is that the two events are related and that this constitutes a short-duration cluster of materials encountered by the Earth-Moon system, says Cook. One of the Lunar Monitoring Program goals is to identify new streams of space debris that pose a potential threat to the Earth-Moon system. The March 17 event seems like a good candidate. NASA's Lunar Reconnaissance Orbiter controllers have been informed of the strike. The crater could be as wide as 20 meters, making it an easy target for LRO the next time the spacecraft passes through the impact site. Comparing the crater's scale to the flash's brightness will provide researchers with useful measurements to test lunar impact models. In comparison to Earth, which has an atmosphere to shield it, the Moon is airless and exposed. Lunar meteors have crashed into the ground with frequency since the monitoring program began in 2005. NASA's Lunar Impact Team has detected more than 300 strikes, most orders of magnitude fainter than the March 17 event. Statistically speaking, more than half of all lunar meteors come from known meteoroid streams, such as the Perseids and Leonids. The rest are sporadic meteors, random bits of comet and asteroid debris of unknown parentage. US space exploration policy calls for extending astronauts' days on the lunar surface. Identifying the sources of lunar meteors and measuring their impact rates gives future lunar explorers an idea of what to expect. So, thousands of meteors have impacted the Moon over the last few billion years. The rocks have left their mark, so what would it take to leave behind more than just a crater? Well, a meteor the size and mass of the Moon itself would either destroy it or push it out of its current orbit around Earth, causing drastic changes to our tides. But honestly, all this talk is more sci-fi than hard science. As far as we know, no meteors even close to the Moon's size exist. So it is doubtful that any of this would ever happen. It does not mean that the story wouldn't make big bucks at the box office. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.